So hello everyone, welcome to my new video. So today from this video you will get to know how to read the HVF report properly. Okay, so what is HVF? So HVF stands for Humphrey Visual Field Analyzer. So it is a machine that is used to measure the visual field. So HVF is the static procedure to measure the visual field where there is a fixed target and background illumination is constant, but there is variable intensity of stimulus is projected all over the patient visual field to assess the visual field and also to see the sensitivity of retina. Okay, so this is the hill of vision. So in hill of vision means that the sensitivity of the retina is not equal in all throughout the retina, right? It is highest at fovea, and as we go from fovea to periphery the sensitivity of the retina gradually decrease. Okay, so here this is why the peak indicate fovea, and as we go to periphery there is more reduction of sensitivity of the retina is there. Okay, so this is the concept HVF is based on. There is hill of vision. Okay, so let we know about the boundaries. So boundaries superiorly, we all know that superiorly visual field is 60 degree, inferiorly 70 degree, nasal 60 degree, and temporal 100 degree visual field is there, and the position of optic disc is 15 degree nasal to the macula. Okay, so how to read the report? Start from zone 1. So in HVF there is 10 zones are there. Okay, so we will read each and every zone. Before that we need to understand this concept about decibel and apostlipes. So illumination of the light or the stimulus is actually measured by ASB or apostlipes. So the highest amount of apostlipes the machine can project is 10,000 apostlipes, and the lowest is 1 apostlipes. Okay, so the highest is 10,000 apostlipes. So the more the stimulus, it indicates less is the retinal sensitivity. It means that the patient needs more intensity of light stimulus to see that stimulus. That means the patient retinal sensitivity is less. So always remember that fovea can detect the dimmest light stimulus because fovea is having the highest retinal sensitivity. So these apostlipes are inversely proportional with the sensitivity of the retina, and these apostlipes are expressed in large numbers. So it is quite difficult to arrange those large numbers in the report, and as it is having inversely proportional to the sensitivity of the retina, so it quite difficult to interpret. So this is why decibels are introduced, where decibels are directly proportional with the sensitivity of the retina. That means 0 decibel indicate brightest light, dimmest 0 decibel indicate the brightest light, and higher the decibel indicate the dimmest light. Okay, so this decibel indicate two things: brightness of the light stimulus and also the sensitivity of the retina. Suppose the patient is able to see the light stimulus at 20 decibel. Okay, and one patient see the light stimulus at 30 decibel. Okay, so it means that 20 decibel light stimulus is brighter than 30 decibel. So 20 decibel point is having less retinal sensitivity than the 30 decibel point. Okay, so 20 decibel is brighter stimulus light intensity, but the retinal sensitivity is less there. But if the patient score is 30 or 40 in that specific point, it means at that point the retinal sensitivity is more, because 30 or 40 decibel of light stimulus are more brighter than 20 decibel light stimulus. Okay, so this is the relation, and as it is very easy to calculate in decibel unit, like decibels are directly proportional with the sensitivity of the retina, and also these are expressed in 0, 10, 20, 30, 40, 50. So these are small numbers, so it can be quite easy to express. So that's why this is more popularly used. Okay, so this is the HVF report that we are going to discuss today. So in HVF report there is 10 zones are there. First of all, zone 1 indicate this patient data and test data. Okay, this is the patient data and this is the test data. So in patient data there is patient name, date of birth, gender, patient ID, everything is written there. And test data, stimulus, what type of stimulus is there, background illumination, strategy, what type of strategy, pupil diameter, visual acuity, all those things are actually used here, right? So this is zone 1, and the zone 1 include patient data and test data, and this is zone 2, which is including the reliability indices. where there is fixation loss, false positive, false negative. So during the test procedure, machine put the light stimulus, 5% of his light stimulus, to the optic disc. Patient should not see that light stimulus, but if the patient responds to that specific light stimulus that fall on the optic disc, it indicates fixation loss. That means patient rotated his eyes to see that light stimulus, right? So there is fixation loss. So 33% of fixation loss is quite acceptable, but more than that is not acceptable. Now let's move to false positive. So in false positive, it is also known as trigger happy patient, where in the absence of light stimulus, the patient continuously press the buzzer or the button. So it indicates false positive. And in case of false negative, what it indicates that the light stimulus is projected but the patient is not pressing the button, so it means false negative. So 33% of false positive and false negative are acceptable, more than that are not acceptable. Okay. And this phobia value should be in between 35 decibel to 40 decibel. Okay, if the phobia value is less than the 35 decibel, it means that the retinal sensitivity is less in phobia. Okay. And this stimulus size are available in 1, 2, 3, 4, 5. So depending on the patient visual acuity, stimulus size varies, but normally we make the stimulus size 3, that is the standard. If the patient visual acuity is less, then according to that visual status, we actually increase the stimulus to 4 and 5. Background illumination is 31.5, that is always constant, and strategy is theta standard. So there is lots of testing strategies are there, but nowadays theta standard and theta fast are used, where in theta standard machine give the patient 3 chances. In 3 chances, if the patient is able to detect the light stimulus, then it is recorded. Okay, and if the patient miss, then it is counted as patient not respond to that light stimulus. Okay. And in theta first, machine give the patient only 1 chance. So in 3 chances that machine give the patient, in the first chance the light stimulus is dimmest, then in the second it is more brighter, then in third it is brightest. So depending on at what specific stimulus patient responded, the sensitivity of the retina is quite dependable. Okay. So these are the point patterns that are used in HVF machines. So here there is 3 types of point patterns are used mostly. There is 30 days 2, 24 days 2 and 10 days 2. So in 30 days 2, total 76 points are available, where they are having difference of 6 degree in between, and here the bare area is 3 degree bare area, where this in 30 days 2 point pattern or 10 days 2 machine don't measure the visual field or retinal sensitivity in bare 3 degree area, and there is total 76 points are there. So this type of point pattern are quite useful in neurological disorders. So 24 days 2 are nothing but the reduction of some selected points from the outermost circle of the 30 days 2, just leaving 2 points here and 4 points here, and all these 22 points are excluded. So 76 minus 22 points, it means 54. So in 24 days 2, 54 points are there. Okay. So these 24 days 2 are mostly used for glaucoma diagnosis, where we see the glaucomatous field image mostly in arcuate area and also nasal tip. So that's why according to that the point pattern are there. So this is the 24 days 2, but actually this is not 24 days 2, there is 27 degrees this point are situated, but as the most points are situating at 24 degrees, so it is called as 24 days 2. So now one question will come to your mind, that what is this dash 2? What is so dash 2 is nothing but the arrangement of point. So 24-1 is, it means that the points are arranged in vertical and horizontal meridian along that vertical horizontal meridian, and in the dash 2 this point you can see there is points are separated from this horizontal meridian by 3 degree from each other. So this is the difference between dash 1 and dash 2. Okay. This is the 10 days 2. So we are having 30 days 2 and 24 days 2. So what is the importance of this 10 days 2? So 10 days 2 actually measures the central area more accurately, because earlier I told you that in 30 days to 24 days 2, 3 degree bare area is not measured. So in 10 days 2, there is total 68 points are there, and there the point difference is 2 degree and the bare area is 1 degree. Okay. So it means that this 10 days 2 can measure the visual field defect more accurately than 24-2 and 30-2. So if we find some type of visual field defect or advanced glaucomatous field defect, we definitely go for 10-2 to see the extent of that field defect, how much depth it is. Okay, now let's move to report reading again. So in report reading, this is the raw data and this is the grayscale. So these raw data are nothing but direct expression of retinal sensitivity that is measured in decibel unit by the Humphrey visual field machine. Okay, so this, if you get the raw data 0, it indicates that there is absolute scotoma. So highest raw data can be available is you can say it is 40 decibel. That is, fovea is having the 40 decibel. Okay, and as we go to the periphery, the raw data values are quite decreasing manner. So you can see that in central 5-degree area or central 10-degree, the sensitivity of the retina is quite high, because it is quite high amount of sensitivity is there in that 5-degree to the fovea or 10-degree. But if we go to the periphery, then you will see the reduction of this raw data values are there. So don't directly give your comment in glaucoma diagnosis only by seeing this raw data, because machine is having its normative value depending on specific age. So these raw data are age specific. Machine compare this raw data with its stored age normative value and then measure the deviation from this raw data and plot in total deviation numerical plot. So before giving any comment, look at the other map also. Okay, now suppose you are having normal vision, normal visual field, not having glaucoma, then also you will not have equal amount of this number, because I already told you that retinal sensitivity is not equal in all the points. It is high at fovea, and as we go to central to periphery, it is quite decreasing manner. Okay, so this is the grayscale. So grayscale is nothing but the gray shade expression of this raw data. Okay, so machine is having decibel value of 50 decibel to 0 decibel, right? So this 50 decibel to 0 decibels are quite graded in 10 group. Okay, 50 to 40 in one group, then 40 to 35 in another group, then 35 to 30 in another group. Like similarly like that, it is going on up to 0 decibel. As the decibel value reduce, the brightness of the light actually increase. Okay, it means that the retinal sensitivity decrease. So if someone is having retinal sensitivity 30 decibel, and that means in a specific point the retinal sensitivity 30 decibel, and in other point it is 20 decibel or 15 decibel. That means in 15 decibel point the retinal sensitivity is less than the 30 decibel point, because 20 decibel is brighter light stimulus there, and if we compare that light stimulus status in 30 decibel point, so that 20 decibel will appear in quite blackish manner if we compare with the 30 decibel gray scale. So this gray scale tells us what is the depth of visual field defect, and also what is the extent, what is the shape of that visual field defect. But we should not fully rely on this gray scale, because gray scales are also having some amount of demerits. Okay, so that's why we should not rely on this gray scale, we should go for other map also. So this is the total deviation numerical plot. So machine is having is its normative value from 0 to 100 years of age. Now machine will compare the normative data with the patient raw data and find the deviation, and then plot it in total deviation numerical plot. So total deviation numerical plot is expressed in three ways. Some appear with no sign in front of it, some appear as 0, some appear as minus sign. So the more minus indicate more amount of deviation from the normal value. So here we can see that there is in periphery -8, -16 are there, and here -1 is there. So this -1 and minus 16, so difference is quite high, so it indicates in this area there is quite possible that the visual field defect is there in this area if I compare the what to say difference. So in case of generalized field defect, the difference between the lowest value and highest value is very less, but in case of localized field defect, the difference between the lowest and highest value is very high. So it tells us what is the pattern and what is the pattern of the hill of vision after seeing the total deviation numerical plot. But this total deviation numerical plot is also having some amount of demerit. So what is the main purpose of doing HBF? So we do HBF to detect the glaucomatous field damage. That is the main purpose. So in case of generalized field defect, that is due to refractive error, cataract, or any other injury, something like that, so we get a generalized field defect is there. But due to that generalized field defect, we are not able to get the extent and location and depth of field defect properly. So this is quite a demerit of this total deviation numerical plot. So here we need something more better than this total deviation numerical plot. So here comes the pattern deviation numerical plot. So in pattern deviation numerical plot, it works on 7 sensitivity point. So what it is actually, so to measure, to find out the 7 sensitivity point, we arrange the total deviation numerical point values in a chronological order from those numbers who are not having any sign. Then in the second group there is 0, and in the third group there is minus added values are there, okay, in a chronological order, and we find the 7 best sensitivity point. Now after we get the 7 best sensitivity point, we change that number sign to its opposite sign, so that there is 0 deviation but we are getting the depth, right? Add that value with total deviation numerical plot and you will find this pattern deviation numerical plot there. So cataract, refractive error, all those visual field damage that is due to cataract, refractive error, all those things will not have any influence on pattern deviation numerical plot. So from here we can easily get to know what is the depth and extent of visual field defect, okay. So this is pattern deviation numerical plot. So these are global indices where there is mean deviation, pattern standard deviation, visual field index, and glaucoma hemifield test is there, okay. So let's start with mean deviation. So mean deviation is on nothing but it tells you that what is the amount of visual field defect is there, okay. So in mean deviation, what it does, that it add all the numbers of total deviation and deduct the numbers by its total value, okay, and find the mean. So this mean deviation is expressed in two ways. It can appear with no sign or it can appear with minus sign. So more the minus sign, it indicates more the visual field damage is there and more the deviation of the retinal sensitivity from the normal. So this mean deviation is quite acceptable up to minus 6, but if it is extending beyond minus 6, then it is indicating something abnormal is going on, okay. Now let's move to pattern deviation, pattern standard deviation. So in pattern standard deviation, this is actually telling us the contour of the hill of vision, that whether it is smooth or irregular. So PSD is not having any sign in front of it, but if there is no significant loss of visual field, then it will not have any p value with it. But if there is significant loss of visual field, then it will expressed with p value. So if we see that pattern standard deviation is having p value with it, then it indicates something abnormal going on, and there is quite possible that visual field defect is there, okay. And this visual field index tells the loss of visual field defect, right? So it sometime appear in 98%, some in some patient who are having glaucoma and visual field defect, they are having visual field index of 70% or 60%. That means remaining percent is lost and the percent remaining is 70%. If the patient visual field index appear expressed in 70%, that means 30% of field is lost and 70% is remaining, something like that. And glaucoma hemifield test, so this glaucoma hemifield test, what it actually does is it actually compare the corresponding point of upper and lower point that are arranged in horizontal axis. So this GHT is having 5 zone, and it compare each zone with its mirror points and find the deviation and find the arrangement, all those things. So this GHT can appear as outside normal limit, or abnormally low sensitivity, abnormally high sensitive, borderline, or within normal limit, something like that. Okay, now let's move to this chart, where first of all you need to see the reliability indices here, and here you can see this is 2 by 16, false positive 2%, false negative 6%. It is quite acceptable, but phobia is sensitivity is 2 decibel less than the normal is 35 decibel. It is quite less, but we can rely on it. So this is the raw data. It is we can't say this is normal or abnormal by seeing the raw data, so we need to see the total deviation numerical plot, and here you can see -1, -7, -7. So all these things, there is not that much high amount of deviation is there, but in the most periphery we can see 30, 12. So if we measured the lowest value, that is 0, and highest is 30, so here -30 of the deviation is there, so it indicates some kind of localized field effect is there. So here you can see in this plot, here the black points are there, indicating there is quite loss is there. So this total deviation, this plot is also having some amount of demerits, like it is based on the p value, that we can see the higher the p value, it indicate there is less amount of visual field effect, and lesser the p value indicate more amount of visual field effect. So if that deviation, total deviation is more than 10, it will having p value less than 0.05. so this p value of -18 and -30 both will have black points. So this cannot say that what is the depth of field effect by seeing this plot. So we need to see the mean deviation and also this pattern deviation for that. So in pattern deviation, here what is the 7 sensitive point? So 7 sensitive point is -2. Okay, so this -2 is add with all those things by changing its sign, and this is the value where here is some amount of localized field effect is there. And in case of global indices, if we see the mean deviation is in the normal range, that is -5, but PSD is expressed with p value with it. That means there is significant visual field effect is there. VFI is also less, 89%, and GHD is outside normal limit. So it indicates that there is glaucomatous field effect is there. So it is a suspected case of glaucoma but not established. So always remember that do not compare the glaucomatous field effect by only looking at the HVF value. You all need to see the disc status also. In this point, this hemianopic field damage is there. Okay, so here half portion of this side is damaged, and here in total and pattern deviation is also showing the similar like that. So always remember that PSD in case of irregular or localized field effect, PSD value will be high, but in case of generalized field effect it will be less. Okay, but this PSD value will not tell you what is the depth or depth of visual field effect is there, but mean deviation will tell you what is the actual damage or deviation. Okay, so this PSD is very high. Why? Because there is localized field effect is there in this portion. Okay, temporal side, and mean deviation is also quite high. Okay, so PSD is expressed with p value, and VFI 48%, GST outside normal limit, so it is indicating glaucomatous field effect. So it can be due to glaucomatous field effect, it can be due to a neurological disorder, where we can see most of these cases in case of neurological disorders. Okay, there is a damage, if damage is happening in the visual pathway. Okay, now this is the report of 30 days 2, where you can see that this is the 24 days 2 and this is 30 days 2. 30 days 2 will appear in a circular manner, and this is the optic disc. Okay, and this is the 24 days 2. Okay, so in 30 days 2 the point arrangement are there, but we can not, there is quite You can see this is also the suspected case of glaucoma, but we can't comment before, not by not seeing or not examining the optic disc. Okay, but this PSD is expressed with p-value, GST outside normal limit, uh, are telling that yes, it can be a case of glaucoma. So another thing, we need to look at the Anderson criteria, where in Anderson criteria 2 point of point pattern deviation should be less than 0.05% and 1 point should be less than 1%. PSD should be expressed with p value when GST should be outside normal limit. Then we can say there is early changes of glaucomatous field defect is there. So it is a suspected case, something like that. Okay. So if we see there is significant damage or advanced glaucomatous field defect, then we have to move for 10 days to see the detail or more advanced quality of visual field assessment or retinal sensitivity assessment. So here this is the 10 days to point pattern, where we can see there is localized field defect is there, but just except this area. So it is a established case of glaucoma, where there is visual field defect is there in this superior portion, as also some portion in this lower. Okay, thank you so much, and I hope this video helped you little bit to read the HBF report properly. So thank you so much, and please don't forget to like my video and subscribe to my channel.